So I've drawn a couple of Lewis structures here, and what I wanted to do is talk quickly about lone pairs, bonding pairs, and electron groups. And honestly, electron groups is something that we'll cover more of on the next chapter, but it's important that you start thinking about this early because it'll help you when we talk about shapes of molecules. Because right now, really all we're doing is talking about how they're connected. You're really not implying anything about the shape. So a bonding pair is a term that they use to describe any pair in a single, double, or triple bond. Okay, so if I'm looking at bonding pairs on nitrate ion, right, there's 1, 2, 3, 4 bonds, so there's 4 bonding pairs on the central atom. And then there's no lone pairs. Now there are lone pairs on the oxygen, so this is for the central atom. Okay, but the oxygens have lone pairs, and lone pairs are again these electrons that are paired off on the oxygens. So there are 3 lone pairs on this oxygen, 3 lone pair electrons on these lone pairs of electrons, and then 2 lone pairs here. Now for the nitrogen in this molecule, right, we have 1, 2, 3 bonding pairs. So 1, 2, 3 bonding pairs and 1 lone pair. And then on the chlorine, there's 3 lone pairs and 1 bonding pair. On the fluorine, on the oxygen, and we have 2 bonding pairs and 2 lone pairs. Now, I did want to point out, like I said, something called electron groups. And a group is a single bond, a double bond, triple bond, or a lone pair. And it doesn't matter, each one of these counts as a single group. And the way we can think about electron groups is they are on the same side of the atom together. For example, let's take a look at this nitrogen. There's an electron group that's a single bond here to this oxygen. There's a double bond, which is an electron group to this oxygen. And there's a single bond, which is an electron group to the nitrogen. So in total, when we're talking about electron groups, on the central atom, there's 3 electron groups. We also try to identify the lone pairs on the central atom, and we have 0 lone pairs. So the double bond doesn't count as 2 groups, it counts as a single group. And here what we have is 1, 2, 3, 4 electron groups. So the lone pair will count. This bond counts, this bond counts, and that bond counts. So what we have is 4 electron groups. And 1 lone pair. And so when we're doing this kind of analysis, we're not looking at the lone pairs that are not on. We're only looking at lone pairs on the central atoms. The ones that aren't, we're not looking at those. So for this structure, for this OF2 molecule, right, there are 4 electron groups, 2 of which are lone pairs. So I'm going to just call it EG, and then 2 lone pairs. And again, lone pairs count as part of the electron groups.